So the other day I received this nice little guy that will let me read analog inputs for the Raspberry Pi. It is an I2C connection, which happens to work very nicely with this the PCF8591, which I talked about in my last 18-minute video. Again, I already have the real-time clock I2C, I2C. Again, with most of these devices, it has both male and female, which is very nice. So you can just add on 8 more. This gives you 4 inputs and 1 analog output. You can change the address, so you can have 7 of these. And you can also, it also comes with a pot that you can move this over, and then it uses the pot so you can adjust the voltage. So the sensor I chose for the analog is a simple light sensor. This came with a kit but was 5. I was a little bit worried because it said 5 volt, and so I was googling, and it said to use a 10K ohm resistor. And I don't know if this is gonna work, but there's a resistor right there, and it is 103, and so I did a simple look and found out that was 10K ohm. So now again, this is 5 volt. So first I'm going to plug in the 5 volt and ground, and make sure this is also set there. Now I only have a few female to female cables, so I'm just going to reuse this. Okay. So the first 4 are the inputs, and the last one is the output, analog output. And I'll include all the source code for this later. So now we turn on the Pi. So this is my program in action, and hopefully I'll have a split screen showing you exactly what I'm doing. I'm going to turn the flashlight and shine it straight at it. And I'm using Ncurses for the first time. This is not completely my code. I stole quite a bit from a website that I'll post in the notes underneath. And also all the source code for this I'll put on GitHub. And as you can see, in complete darkness, and then whoop, and then if I show it at light, so as you can see, it works quite well. So you might be wondering what the next logical step is in this sensor little program I have. Well, I decided I wanted to be able to take this outside and show this around and make it mobile. So in order to do that, first I had to have some way of displaying the information without lugging around a huge TV screen. Now this kit came with this nice LCD. It's a 16022. It's just a simple 16 by 2 blue LED. And of course, thanks to DVK, you just snap that in, and then you're good to go. So I'm going to just show an example of this. I'm going to see if I can zoom in. So this is basically the same thing. It shows the asterisks to represent how much light is being shown. And you can see the asterisks representing approximately how much light it is sensing. And so now that I can take this anywhere I want to. It actually has a nice purpose now. And again, I'll put all this source code for that I did on GitHub and post the link on the notes. And I hope you enjoyed the show.